Our first two examples dealt with driving in cars, riding in trains, and they both dealt with rates. It's a rate of change, but not every rate of change is velocity. It's not always the rate at which you are traveling, miles per hour, or in this case it was miles per minute. Now it is going to be John turning on the water to fill a large basin, like a tub of water, that initially has 14 gallons of water in it. We have a starting point. Water flows into the tub at a rate in gallons per minute shown in the graph below. So what's the equation? We don't know, but we have the graph. It's piecewise, and we could make an equation if we wanted to. I choose not to. This is the rate of water flow. It is for all our purposes, this is a very poor interpretation of physics, but based on what we just did, it's kind of like velocity. It is a rate of change, like velocity is a rate of change. It's not velocity of water, but it is the rate at which something is changing, and we're going to treat the concept the same. So I'm standing here waving my arms talking about it, and you can't even see my arms. So those are my hands. Here we go. Let's figure this out. Water flows into the tub at a rate in gallons per minute. So this axis represents gallons per minute, and this axis is going to represent minutes, if I could spell it correctly. And so the same concept applies, exact same concept, where if I found the area under the curve, I call it a curve. Curves can be straight lines for our purposes. If I found the area under this curve or under this curve, they're not curvy yet, then I would know the quantity. The area under a rate gives me a quantity. That will be so important later. And again, if this was one big rectangle, the whole thing was a rectangle, I would find the area by going gallons per minute times minutes. Minutes cancel, I get gallons, we're good. How much water is in the tub at the end of 16 minutes? Let's find out. This is fun. You're going to love this. How much water is in the tub at the end of 16 minutes? I need to know how much water went into the tub. I also need to know what I started with. Don't assume that the tub was empty. It wasn't, okay? So I'm gonna write down a lot of unnecessary things, but they help us understand. So 14 is my start. Plus, how much water went into the tub? I don't know, but if we find the area of this, we'll know it. And here's what we're gonna do. We're gonna find the area of the individual pieces. We're going to find that area, and that area, and that area. Let's call them by name. Trapezoid from 0 to 4, 0 to 4 minutes. Rectangle from 4 to 14 minutes. Triangle from 14 to 16. And it's going to take a little bit of geometry, but that never hurt anyone, I don't think. So we're going to have a trapezoid, and the formula for the area of a trapezoid, I think this is worth writing. This will come in another lesson. Area of a trapezoid is 1/2 the height, which is the distance between the two bases. The bases are the parallel sides. And in this case, then let's use a pencil here. This is the height, and these are the bases. So I didn't leave myself much room for doodling, but I'm going to put trapezoid, and it is from 0 to 4. Okay, just using interval notation here. Let's change colors for the rest of them. We're going to have a rectangle, and it is from 4 to 14. And we're going to have what color? Purple. Good call. A triangle, and it is from 14 to 16. Okay, I'm doodling here. This is just my words explaining what's going on an AP test. You don't have to be like the trapezoid from 0 to 4 and the rectangle from 4 to 14. You don't have to. I'm just telling you where everything's about to come from. Let's jump back in with green. Here we go. Trapezoid from 0 to 4. 1/2 height. The height is the distance between the two parallel sides. It's 4 in this case. And we're going to have this distance, which is 4, plus this distance, which is 6. All right, moving on. Plus this rectangle, don't make this one harder than it is. It's the distance from 4 to 14 times the entire height, which is 6. And we switch to triangle. Am I going too fast? Slow the video down if you need to. Triangle, area of a triangle is 1/2 base. Where's my pencil? That's the height, that's not the base, but I wanted to draw it anyway. Base times height. 1/2 base times height. Okay, let's assume this calculator is inactive. Let's assume the problem is calculator inactive. That's what I'm trying to say. And we're gonna go 14, oh, let's keep the colors flowing, plus 2 times 10, so 20. This will slow you down if you do this on the AP test. Switch pencils in between each problem, in between the parts of the problem. Don't do that. 6. And here we go with our calculator inactiveness. And we add all those together, and we are going to have 100. We have 100 gallons. I don't know what color to use for the final answer. I'm stumped. We'll use black. 100 gallons. 100 gallons of water. Now we get to a tough question. Assuming that the tub is now filled to capacity, at what time was the tub half full or half empty, depending on your outlook on life, okay? So we want to know when the tub was at 50 gallons. Let me rephrase the question. When were there, when were there 50 gallons, we'll stick with 50, we'll stick with were, I should say, 50 gallons in the tub? This is kind of a tough question that's not really calculus related. Can we reword this a little bit? If we start with 14 gallons and we want to see when there were 50, we really want to know when had, subtract 14 here, 36 gallons been added to the tub. That's the question, okay? So 100 gallons, 14 before we ever started this graph, and then we added 86 more. And so then I want to know, well, when did we have 50 gallons? Well, I really want to know when were there 36 gallons added. That's what I need. So can we just go ahead and talk about the fact that the 36 gallons is going to happen somewhere during this rectangle? And I'd like to think that's obvious, okay? So 20 gallons came in right here. 20 gallons, how do you know? It's a green trapezoid. 20 gallons here. You want to see more color coding? You can shade it green. We got it. Stop coloring. There we go. There's that. And where's purple? There you are, purple. Thanks for not running away from me, purple. That's it. So that's what we're dealing with. And I believe, and I know for sure, because I'm looking at the answer on my scrap paper, but I know for sure that we reached a total of 50 gallons or an input of 36 gallons somewhere in here because, again, 20 gallons, and then 80 gallons, that's 20 plus 60, so 36 had to happen in here, all right? So let's figure out where that happened, and we're just going to walk through a process. Knowing that, and I'm writing my thinking, articulating my thoughts so no one gets lost. Here goes. We had 20 gallons added. I'm ignoring the 14, okay? I'm not aiming for 50 gallons anymore. I'm aiming for 36, an area of 36 on this graph, okay? We had 20 gallons added at t equals 4, what, minutes? Yeah, minutes. We need, I'm articulating my process in my brain. We need how many more gallons? 16 more gallons. Okay, it's going to happen during this rectangle. This rectangle has a height of 6. So I need to start here and get an area of 16 with a height of 6. So this width, I'm going to call it B for base, times 6 will give me 16. So B equals 16 over 6, which is 8/3. All right, that is not my final answer. This 8/3, in case you care, that is 2 2/3, 2.6 repeating. That's going to happen when 2 2/3, about right here, about right there. And that happens at 6 2/3. So the 4 minutes that already elapsed to fill in the 20 gallons plus the 2 2/3 minutes is going to give me 6 2/3 minutes. At 6 2/3 minutes, we had 50 total gallons.